The James Webb Space Telescope is transforming our understanding of the universe in ways we've never seen before. It's giving us a new perspective on our own planets, the most distant galaxies, and some of the strangest phenomena in space. And believe it or not, it's only been a few weeks since its launch. There are many more exciting discoveries on the horizon. This remarkable telescope is the result of decades of hard work by scientists from around the world. For those of us in the field of astronomy, the arrival of the James Webb Space Telescope is a momentous occasion. It represents a true revolution in our observational capabilities, unlike anything we've had access to before. The James Webb Telescope boasts an extraordinary feature: its colossal mirror. This mirror is groundbreaking in several aspects, chiefly due to its immense size, making it the largest mirror ever sent to space. To visualize its scale, it spans a staggering 6.5 meters, surpassing the size of most houses. It's so vast that it couldn't fit into the rocket without ingenious folding, allowing it to snugly fit within the rocket's payload fairing. This sheer size makes a huge difference in terms of the telescope's sensitivity. In fact, the James Webb Space Telescope is thousands of times more sensitive than its predecessor, the Hubble Space Telescope. To be more precise, it's a leap forward of several thousand times in terms of sensitivity, which is truly remarkable. This technological advance is a rare and monumental step in the history of science. The size of the mirror on the James Webb Space Telescope matters a lot. The bigger the mirror, the more light it can collect, and the larger the collecting area, the more sensitive the telescope becomes. This heightened sensitivity allows us to peer further into the depths of space than ever before. Another extraordinary aspect of the James Webb Space Telescope is the precision with which it's been crafted. To put it into perspective, if you were to stretch the mirror to the size of the United States, the largest bumps and dips on the mirror would only measure about 1 centimeter in size. This precision is what produces nearly flawless images from the primary mirror. However, it's not just the mirror's size and precision that make the James Webb's images exceptional. It's also the type of light it detects. The telescope focuses on infrared light, which is a wavelength of light that's invisible to our eyes, but its unique properties make it incredible for exploration. In the realm of infrared light, we can observe the atmospheres of exoplanets, study molecules in star-forming regions, detect substances like caffeine, alcohol, and water ice, and even search for the signatures of life on other planets. In essence, infrared opens up a whole new world of possibilities for astronomers like Olivia, enabling them to capture images that would have been impossible in the optical range. But within the infrared spectrum, there are various wavelengths. On board the Webb, there are 3 instruments that observe near-infrared, which is closer to the visible spectrum. However, the instrument that's drawing global attention is the mid-infrared instrument known as MIRI. MIRI is indispensable for the James Webb Space Telescope because it allows us to see cooler phenomena in the universe and look back into the earlier stages of star formation, which is something we've longed to do. MIRI, the mid-infrared instrument, is an immensely significant and crucial component of the James Webb Space Telescope. It provides us with images of far greater detail and clarity than ever before, allowing us to explore the universe in new wavelengths of light and discover unexpected phenomena. MIRI's ability to observe along the extended infrared spectrum enables us to see through dust clouds and look further back in time. As galaxies move away from us, the light they emit shifts deeper into the infrared part of the spectrum. Therefore, by observing longer wavelengths, we can peer further back in time and gain insights into the early universe. Surprisingly, MIRI almost didn't make it on board the James Webb Space Telescope. Initially, it wasn't part of the telescope's plans because it was seen as technically complex, and the scientific objectives were viewed differently. However, advocates like Gillian Wright, the European principal investigator for MIRI and director of the UK Astronomy Technology Centre, made a compelling case for the inclusion of a mid-infrared facility. Gillian's efforts paid off when it was confirmed that MIRI would be part of the telescope's instrumentation. This achievement brought joy, but it also meant years of hard work ahead. The construction of the James Webb Space Telescope began in 2004, and after 17 years of dedicated effort, the telescope, complete with MIRI, was finally launched on Christmas Day in 2021. This monumental event marked the beginning of an extraordinary journey, venturing back in time to the origins of the universe. The anticipation for the James Webb Space Telescope's launch had been building for many years, and as Christmas Day approached, the excitement and nerves were palpable. I was so eager to witness the launch that my family might not have fully enjoyed Christmas morning with me. The Webb launch was on the TV, and I was anxiously watching, with pillows at the ready in case I needed to hide. Fortunately, everything went off without a hitch, and it was a truly incredible launch. It was a delightful and unforgettable Christmas present. In the following months, the James Webb Space Telescope embarked on a journey of over 1.5 million kilometers away from Earth to its new home. Along the way, its instruments were gradually turned on. This part of the journey was filled with excitement and tension, as there was always the possibility of technical hiccups after decades of meticulous work. Finally, the James Webb Space Telescope quickly became fully operational, and the initial images didn't disappoint. My high expectations were surpassed as the first images turned out to be breathtaking and exceptionally beautiful. It was a truly amazing moment, and the telescope's performance exceeded all expectations. Since that moment, I've been wearing a constant smile, and my emotions have been running high. The images captured by the James Webb Space Telescope are not just spectacular. They are a window into astonishing discoveries waiting to be unraveled. One of the remarkable aspects of these early images is how MIRI, the mid-infrared instrument, adds an incredible amount of information. These images reveal details that we knew existed, but never thought we'd see with a scientific instrument. For instance, some of the first images released included the Southern Ring Nebula, a planetary nebula signaling the end of a star's life. In the MIRI image, we not only see the red star, but also a white star, unveiling that this is, in fact, a binary star system. This marks the very first time we've spotted this binary companion in the Southern Ring Nebula. Another awe-inspiring image is of Stephan's Quintet, a group of 5 galaxies interacting with one another. In one of the galaxies, we observe material spiraling into a black hole in an active galactic nucleus. We can witness this material orbiting and being drawn into the galaxy, providing a view that extends 13 times further than what we've ever seen in the infrared spectrum. The James Webb Space Telescope has quickly uncovered extraordinary findings, including distant galaxies with the highest redshift and nearby ones, all in its initial weeks of operation. These discoveries hint at many more exciting revelations to come. Webb was built to address existing cosmic queries, but like all pioneering telescopes, it also unveils unforeseen mysteries. These enigmas will spark new questions and challenges, often beyond our current comprehension, making the exploration truly thrilling as it reveals the unexpected and the unseen.